All right, so let's see if we can straighten out a hard polar graphing question. So I have right here, r of theta is 3 times the cosine of twice theta. Okay?
Shifting rules and normal shifting.
Yeah, no.
I didn't think so.
Don't even try the normal shifting rules. They work on this one in the r theta plane. You guys see that?
Yeah.
Okay, so we could draw that, and it's not a bad idea, so I'm going to start there. But keep in mind, this is not the xy plane, so this is not the answer. Cool? So we're going to go over here into our r theta plane. So we're going to let theta be the input value, right?
Yeah.
And we're going to let r be the output value. And then we're going to think to ourselves, okay, I have cosine, right? So what's cosine look?
Starts at the high point.
Good. Okay. Cosine starts the high point and then kind of oscillates, right? Oops, shit. Ignore that part. I'll stand in front of that. Okay, so this here, right,
It's usually at 1. but now
is usually at 1.
But now
it's
it's
multiplied by 3.
And I made a horizontal or a vertical inflation by 3. So that's at 3, and the trough is at
Negative 3.
-3. Cool. All right, so I already know that my radii are going to vary between -3 and 3, right? You guys see that? So I know one thing about this, which is that my ultimate picture here in the xy plane is all going to live within the circle of radius 3.
Right.
You guys see that? So if you get fancy polar graph paper, it'll look like this.
Whoa.
I'm doing a shit job with this.
Yeah, that's good.
Maybe I'm not doing a terrible job. It's just not good. You guys see this? So I have the radius 1 circle here, the radius 2, and the radius 3 circle there. I know this whole picture is going to live inside the big dotted circle. You guys with me on that? Good. Perfect. Because the radius, right, lives between 3 and -3. And either way, it's still smaller than 3 in absolute value. You guys with me on that? Okay. Where's this first crossing normally occur?
Normally it'd be at
Normally it's at pi over 2, but I horizontally compressed, so now it occurs at pi over 4. This trough normally occurs at pi, so now it occurs at pi over 2. This crossing normally occurs at 3 pi over 2, so now it occurs at 3 pi over 4. You guys with me on this? Okay, now I would personally recommend that you drop this half and continue this until you get to a full 2 pi. So this guy is normally at 2 pi, now it's at pi. And then these go up by pi over 4s, right? So this will be 5 pi over 4, 3 pi over 2, what's that one at?
7 pi over 4.
7 pi over 4, and this guy is at 2 pi. Okay, so why did I want you to go till you got to 2 pi?
That's a full rotation.
Good, because that's a full rotation, right? So what I'm going to do is I put my radii in black on here, and now I'm going to put the important angles in blue. So what are your important angles? Yeah, every pi over 4, right? So every 45 degrees. So split your picture into pi over 4s. You guys with me on this? Cool. So you can buy polar graph paper that's set up this way, or we can print you some in the math lab if you want. I usually just make it every time, but whatever. If you guys want to get some, have at it. Now what do I need to do?
Graph easy points.
Yeah, graph the easy points. So at angle 0, what's the radius?
3.
Radius is 3. So at angle 0, I go out to 3. Okay, so we're starting there. And now what happens to the radius as I go from angle 0 to angle pi over 4?
It drops to 0.
Goes to
Okay, it drops from 1 to 0. So as we change our angle from 0 to pi over 4, the radius is going to come in and it's going to hit 0. You guys see that? Now how you draw this is kind of funky, but it looks like flower petals.
That's good.
Yeah, roses.
Yeah.
I can see that.
Let's call that. Question, Steele? So I really just connected those dots with the angles in between.
So why is the 1.00?
So this guy here, right,
Yeah.
corresponds to the polar point 0 in the radius, comma, pi over 4 in the angle. When the radius is 0, I don't care what the angle is, right? It's always 0, 0. You guys see that? So that's the origin. And I'm going from this polar point here, which is radius 3, angle 0, to that. And I have to do that in the angles between 0 and pi over 4 with the radius going down. So I just sort of thought, okay, well, if I increase the angle and the radius goes down, well, those are going to be kind of coming at me. Okay, now the next set is going to go from 0 pi over 4 to where? Where's this next point at?
It's in the third quadrant.
3 pi.
Okay, so this
Yeah,
is
2 pi.
pi over 2 in the angle, right?
Negative 3 radius.
So I'm looking up 90, right? But back 3 in the radius, so I've got to point down here. And I'm starting here. Okay, see that? The radius is always negative in there. Right? So that's going to be going through, where does that live, guys? You see it?
Is
This-
this third quadrant like this?
Yeah, that's right here. You guys all see that? Because it's happening in this quadrant, or this little octant, or whatever this thing is. But it's flipped over because the radius is negative. So those are going to start here and go through this stuff. Is all good? Yeah.
So when you do the x, what if like the whole thing was at pi over like 6, not pi over 4?
Oh, what if these were pi over 6s?
Yeah.
Then I wouldn't have made x's, I'd have split these into 3 pieces. Yeah, so you might have to split this into more pieces depending on what this number here is. So where's our next one? Our next one goes from the dot at the bottom there, still negative radii, right? The angles are up here. You guys see that? So my petal is going to be right here. And it should just be the opposite of the petal I just drew. Something like that. You guys with me on those? The negative ones are damn hard. You really could just go through and do the positive ones.
And then just flip it.
Yeah, and then flip them. They won't necessarily be exactly symmetrical. Let's see, so then my next guy should be positive and easy to draw. And it's between 3 pi over 4 and pi.
So second.
Right, so that's these angles in here. And I'm going from the origin up to, 3 comma pi. So I'm going from 0 radius up to 3 radius. And I'm just doing that nice and smooth, looks like a petal. Then my next one's going to go from a radius of 3 down to a radius of 0 through the next set. You guys see that? So that's going to look like the other half of that petal. Cool, good. And then the next ones are negative. Where are those going to be?
First quadrant.
Yeah, this one's going to be the first quadrant, that one's going to be in the second quadrant.
Just other side.
But those are going to be this petal and, or this half a petal and that half a petal. And then where's the last one?
It's the other side of the first petal.
Yeah, the other one's the obvious completion here. You guys cool with this?
Are we all gonna look at this?
Yeah, lots of. So, lots of them look like this. It's possible to make them that don't look like this. So one thing I noticed here is that I got twice this for petals, right? You guys see that? I had a 2 in here and I got 4 petals. If I had a theta over 2, I would end up with 1 petal, which is kind of strange. 1 petal looks like a circle to the side. So there's some kind of funky circles that can happen here too. But yeah, generally they look like some kind of flower petal. Cool?
If you
Questions?
quickly sketch, theta over 2.
Yeah. So if I thought of r of theta is 3 cosine of theta over 2. So we do the same thing, right? So this guy starts at the top, right? And oscillates. And now this is normally at pi over 2, right? But now it's going to be at pi.
So this shortens
And the trough is normally at, oh shit, I didn't really care about the trough. This guy is normally at 2 pi, right?
3 pi over 2.
Oh, what am I saying? Oh my god. This is normally pi over 2, now it's pi. This guy is normally 3 pi over 2, now it's... How about this guy's normally... What am I doing? I don't know what I'm doing either. Help, I need an adult. Okay, so let me relabel. So this is normally at pi over 2. Oh, that's my issue. So this is normally at pi, this is normally at 3 pi over 2, and this is at 2 pi. Right? But then I've stretched the other way by a factor of 2, so I dropped the over 2's. So this is at pi, and this is now at 2 pi. And none of the rest of this crap matters because I went once around. You guys with me? Okay, so what's my once around look like now? Well, between the angles of 0 and pi, right, I went from a radius of 1 to a radius of 0. You guys see that? So, starting out here, at 0 and pi, I went from like this. You guys see that? And then on the other side, we're going from a radius of pi, or a radius of 0 back up to a radius of 1. So we'll get the other half of this dude. You guys see that? Cool. Other things are sort of possible and pretty messy. You can make other cool things. You can make really cool things by doing something like r is theta. This is a cool shape.
That's spiral.
Yeah, this is some kind of a funky spiral. You can make some other kind of funky spirals by doing r is some kind of increasing function of theta. So for instance, one of these might be like e to the theta, kind of an entertaining picture. This is basically a faster spiral. There's other kinds of spirals you can make this way. Some of them have much relevance to biology and other things.
And we're unable to use a calculator, the theta.
Not necessarily. If you have the right calculator and you know how to use it, you
Which
can do
is?
some of this.
But
Which is the TI-84 colors can do some of this.
No,
But yeah, the regular TI-84s I think are a little wobbly. You can get them to do some of this, but not a lot of it. If you have, yeah, Gabe's fancy calculator will do a lot of this. Oh, Justin's fancy calculator can do a lot of this.
I actually have a question about the one that you just did.
Oh, did I screw it up?
These could